All right, today we are doing 5.6, solving by completing the square. So another strategy for solving quadratics. This whole chapter, right, all of chapter 5 has been about solving quadratics and different ways to do it. So our objective today is to solve quadratic equations by completing the square. All right, the cool thing about this method is that it can be used to solve any quadratic equation. Okay. Equations in which the left side is a perfect square trinomial can also be solved by taking roots. Okay, so that's helpful, but we're going to be completing the square. Okay, so that'll make a little bit more sense in a little bit. So example 1, we have solve x squared minus 8x plus 16 equals 49. Okay, so completing the square, we want to rewrite the perfect square trinomial, okay, because this one's a perfect square trinomial. So this is what it's talking about, equations in which the left side is a perfect square, which is this one. So we're going to rewrite the perfect square trinomial as a binomial squared. Okay, that's what we're going to do. Now, and then we're going to solve it by taking roots. Okay, so let's take this part. Okay, and remember I've told you like you need to memorize those perfect squares, like the sum of squares, the difference of squares, and things. So this is a perfect square, and it's subtraction. All right, so if we write this as a perfect square trinomial, the square root of x squared is x. The square root of 16 is 4, and it's subtraction, so it's x minus 4 squared equals 49. Okay, so we took that part on the left side, that's a perfect square trinomial, we rewrote it as a binomial. Okay, and then we're going to solve by taking roots. Okay, so I'm going to take the square root of this side. It's going to give me x minus 4. The square root of this side is going to give me plus or minus 7. All right, so then we need to add 4 to both sides. So x is equal to 4 plus or minus 7. Okay, so that's one way to write our answer. The other way is to actually find out what that is. So what is 4 plus 7? Well, that's 11. Or we can do x equals 4 minus 7. So x equals negative 3. So we would say x is 4 plus or minus 7. And then, well, and then we could say that equals 11 negative 3. Those are our other options there. Okay, so we can write it in a couple of different ways. All right, so it's helpful to know that. And then now that we've done this first step, it's going to help us see how we're completing the square. Okay, so every quadratic can be changed into an equation where one side is a perfect square trinomial. That's what we're doing. We want to get a perfect square trinomial. And we're going to use this process called completing the square to get it there, because we want to complete it to be a perfect square trinomial. All right, so to complete the square of an expression in the form of x squared plus bx, notice we don't have a c, and the square of half, we're going to add, pardon me, I cannot talk, we're going to add the square of half the coefficient of the linear term. Okay, so let's look at this. Okay, so we have x squared plus bx. We're going to add this here. We're adding half of the coefficient of the linear term. So we're taking b, that's the linear term, and adding half of it. So the square of half of it. So we have b divided by 2 squared. Okay, which is going to end up with x plus b divided by 2 squared. This is a perfect square. Okay, that's how this is going to work. And we're going to do this to both sides of your equation. So let's actually look at it. Example 2. For each expression, complete the square and factor the resulting trinomial. Okay, so here's the thing. Step 1. We're going to add the square of half the coefficient of the linear term, or the x term, and then we're going to factor the perfect square trinomial. Okay, so we've got x squared minus 6x. Okay, the minus 6 is our b term, right? It's our linear term. So we're going to add that to this. Right, so since that's our linear term, we're going to take this and we're going to add negative 6 divided by 2 squared, which would leave us with x squared minus 6x plus negative 6 divided by 2 is negative 3 squared. So then we'd have x squared minus 6x plus negative 3 squared is 9. Okay. Now is the time we're going to factor this perfect square. Okay, because we have a perfect square here and a perfect square here, and it's subtraction. Okay, so since it's subtraction, we know we have a minus in there. The square root of x squared is x. The square root of 9 is 3. So this is the quantity x minus 3 squared is that shortcut. Okay. Now, it can also be done in b, which has a fraction. Okay, we have y squared plus 5/3 y. All right, our b here is the 5/3, our linear coefficient of the linear term. So we're going to add 5/3 divided by 2 squared. I know that looks really complex. So if that's the case and you're like, this is terrible, remember that it's half. So we could also say that we're going to add 5/3 times 1/2 squared. You might prefer that. Okay, so to do the math, which would give us y squared plus 5/3 y plus 5 times 1 is 5. 3 times 2 is 6. And then that's squared. Now, here's the thing. Maybe you've caught that. Probably not yet. So let me go back. Actually, let's go ahead and do this one. So this way, and then I'll show you a shortcut. So y squared equals 5, or plus 5/3 y, plus, if we square 5/6, right? 5/6 times 5/6 is going to be 25/30. Okay, so now we've got our perfect square trinomial. And this time we have addition here. So it's going to be adding our terms. So the square root of y squared is y plus, and the square root of 25/30 is 5/6. So this is going to be y plus 5/6 squared. Now, here's the thing that you may not have caught yet, but it's very helpful. Okay, so we did the work. We did negative 3 squared, we got 9. But look at how this ended. Minus 3. What was it because we squared this number, right? But we already had the square root of it. It was 3. Or it was 3, not the negative 3, but it was 3. Okay? So very, very handy there. And in this one, we did the square root of 25/30. Well, all we need to do was undo the square that we just did, and we got 5/6. So honestly, you don't even really have to write out this last step. If you get it to here, you're just saying, okay, here's y and the 5/6. You don't have to actually Square the 5/6 or square the -3. It is okay if you don't, because you're just going to turn around and take the square root, which undoes it. Okay, so let's move on. Remember, if you add a number to one side of an equation, you must add it to the other side. Okay, this is helpful and necessary when we have a problem like example 3. Solve x squared plus 10x equals 15 by completing the square. We're going to state the roots as both simplified radical expressions and decimals to the nearest hundredth. Okay, so same thing. We've got this binomial here. We want to make it into a perfect square trinomial. But we have some stuff over here. So whatever we add to the left, we have to add to the right. So let's check this out. We've got x squared plus 10x equals 15. To make this a perfect square trinomial, we're going to add our b value, which is 10. Right, so we're going to add 10 divided by 2 squared. So we're going to have to add that to this side, 10 over 2 squared. All right, so that leaves us with x squared plus 10x plus 10 divided by 2 is, good, 5 squared. That equals 15 plus 5 squared. Okay, because we added the same, oh, it didn't change colors on me. We added the same thing to both sides. We added 5 squared to both the left and the right, so we're not changing our equation at all. It's perfectly fine that way. Okay. Except, let me get over this. This one is fine, right? Because we want to take the square root of both of these. So then I'm going to have x. This is addition. So it's going to be plus 5. So that quantity x plus 5 squared is equal to, how is this helpful to have 15 plus 5 squared? No, it's really not, right? Like on the right side, in this case, we really need to do 15 plus 25, which equals 40. Okay, so now we can solve by taking roots. Okay, so let's do that. So let's take the square root of both sides. And we have x plus 5 is equal to positive or negative the square root of 40. Okay, and we can simplify the square root of 40. Remember I told you in class I prefer to do the division by primes. So I'm going to divide by 5 here. 4 divided by 5 is 8. 8 divided by 2 is 4. Divided by 2 is 2. Which means this is the square root of 5 times 2 times 2 squared, we could say. So since this is a square, we can take it out. So this is going to be 2 times the square root of 5 times 2, or 2 times the square root of 10. All right, that's equal to the square root of 40. All right, so that's going to be helpful. I'm going to change up color so I can see, but I got to get x by itself. I didn't have to do the square root of 40 thing yet, but I went ahead. So we're going to subtract 5 from both sides. So x is going to be equal to negative 5 plus or minus our 2 times the square root of 10. Okay, so x is equal to negative 5 plus or minus 2 to the square root of 10. All right, this is the simplified radical. Okay, that's our simplified radical expression. That's one thing we needed to do. The other is in to the decimal to the nearest hundredth. Okay, so in order to do that, you need your calculator. Okay, let me put it on here. Perhaps I should erase some work. Yeah, let me erase this over here. Well, let me go to my board and erase. I'm a little faster there than with my pen. Okay, so we need to put in the -5, -5, plus we're going to add 2 times the square root of 10. Okay, and if we hit enter, we're going to see that it's kind of hard to see. There's a glare there. Sorry. There we go. Hopefully that's better. So we have 2 times the square root of 10 minus 5. Same difference, totally fine. But on this calculator specifically, there's a toggle button right here that we're going to push. Okay, and that toggle button, notice you can see it right here, like what it looks like, is going to give you a decimal. So this is 1.32 because it said to the nearest hundredth. Okay, so x is, we would say approximately, we're going to use the wavy signs, 1.32. All right, and then we need to do the -1. So we're going to do -5, right, because we're here, -5 minus 2 times the square root of 10. And if you hit, so this is exactly what it should look like here, -5 minus 2 times the square root of 10. If you hit enter, it reverses the form, okay, puts the radical first. It's not how we generally write it. And then you want to hit that toggle button right here, this toggle button, and it will give you the decimal. So that decimal is -11, -11.32. Okay, and that's how we get the decimals. Okay, because we're going to have to put them in our calculator, and in this calculator you have a toggle switch, or a toggle button, not a switch. In a different calculator you're going to have different things, so I can always show you those as well. Okay, so finished up with that one, on to the back. So solving quadratic equations by completing the square. That's exactly what you just did, okay, in example 3. So examples 4 and 5 are just extra practice of that. So we've got to write the equation in x squared plus bx equals c form. So this time our c is over here, right? We want to move it to the other side. So let's add 10. So we've got 3x squared minus 13x equals 10. Okay, notice we want it in x squared form, so there's no a, so we need to divide by 3. Which gives us really ugly looking answers, but that's okay. So my 3 here cancels. So I've got x squared minus, here I'm going to have 13 divided by 3x equals 10 thirds. This is the thing that people don't typically like about completing the square, is that it gets ugly looking. But it's okay to be ugly looking, right? It's fine. We know how to deal with it. All right, so now we're going to complete the square by adding the half of the coefficient, or half of b. b divided by 2, b times 1/2, however you want to do it. Okay, so my b is the 13 over 3. Okay, so I'm going to have x squared minus 13 thirds x plus, okay, and I'm going to do them multiplied by 1/2 this time. 13 thirds times 1/2 instead of dividing by 2 squared. Equals 10 thirds, and I'm going to do the same thing, times 13 thirds times 1/2 squared. Yikes. Okay. So that would give me x squared minus 13 thirds x plus 13 times 1 is 13. 13 times 2 is 6. So 13/6 squared equals, oh, I forgot a plus sign in here. It looks like multiplication. Don't do that. So this is going to equal 10 thirds plus, okay, and let's go ahead and do this math out. 13/6 squared. Okay, so 13/6 times 13/6 is going to be 169 over 36. So 10/3 plus 169 over 36. Okay. And don't think, like, you can use a calculator on some of these, but we've gotten what we wanted here, right? We have a perfect square trinomial, x squared, 13/6 squared, okay? And it's a subtraction. So this is going to be the quantity x minus 13/6 squared. Okay, there was no reason for me to do this math out, if you recall. I'm saving myself some time. And this equals, and this is a perfect place. I would use my calculator, right? To see, well, what is 10/3? If I could find my fraction button. What is 10/3 plus 169 36 equal? Okay, it equals 289. Oh, you can't see it. Doggone, I need to pay better attention. Equals 289 over 36. There's always a time and a place, right, to use your calculator. You don't want to be too reliant on it, but be able to use it. Okay, so we have x minus, the quantity x minus 13/6 squared equals 289/36. So to solve, we need to solve by taking roots. Okay, so I'm going to take the square root of this side, the square root of this side, and I get x minus 13/6 equals, all right, the square root of 289 is 17, and the square root of 36 is 6, and this is plus or minus 17/6. All right, well then I want x by itself, so I'm going to add 13/6. So x is equal to 13/6 plus or minus 17/6. All right, so then we need to do the math out here. Okay, so 13 plus 17, right, is going to be 36 if we add them, which would be equal to 5. And if we subtract them, 13 minus 17 would give you negative 4/6, which would be negative 2/3. So x equals 5 or negative 2/3. And we would put a comma in there. We wouldn't actually write or. Okay, so I was running out of room, which is why I kind of put these together, right, and did 13 plus to get the 36th and 13 minus to get the negative 4/6 for our two answers. Definitely was running out of room. Okay, let's try another one. Example B here. All right, so again, we have to have it in the form x squared plus bx equals c. So we're going to subtract 9 to move it to this side. 5x squared minus 10x equals negative 9. We're going to divide by 5 because we don't want an a term here. We just want x squared. So that's 5 divided by 5 gives us x squared. Ooh, this one's nice. Negative 10 divided by 5 is just negative 2x equals negative 9/5. So we have one fraction, but it's not so terrible. Okay, now we're going to add the square of half the coefficient. So we've got x squared minus 2x plus negative 2 hold on. Yeah, negative 2 over 2 squared. Sorry, I'm forgetting to change my colors back. Equals negative 9/5 plus negative 2 over 2 squared. Okay, so that leaves us with x squared minus 2x plus negative 1 squared. Time out, hold on. This is where we always get, I always get tripped up. The negative comes out when we're making the perfect square, so we don't even take that it's a negative 2x. Hold on. Yeah, we do. Okay, so this is going to be 9/5. Sorry, negative 9/5 plus negative 2 divided by 2 is negative 1. Negative 1 squared is a positive 1. Okay, so then on this one, and see, this is where it gets tricky, because if we can't really have a negative here because we already have this negative. So negative or 1 squared is a positive 1. Like, think this through with me. So we have x squared minus 2x. Negative 1 squared is a positive 1. So when we take the square root of it, it's going to give us a positive 1. So negative 9/5 plus 1, okay, would be negative 4/5. So then we have our perfect square trinomial. So we're going to have x, it's subtraction, so minus 1 squared equals negative 4/5. Okay, now we solve by taking roots. So we find the square root of both sides. So we have x minus 1 equals plus or minus the square root of negative 4/5. Okay, so we're going to add 1 to both sides. X is going to equal 1 plus or minus, and we can simplify this. Okay, we have a negative under our square root, so it's an I. Okay, the square root of 4 is 2, and it's going to be over the square root of 5, because 5 doesn't have a square root. So kind of ugly there. Then we should simplify this, right? We don't want that there. So we'd multiply by the square root of 5 over the square root of 5. So x would equal 1 plus or minus I times 2 to the square root of 5 over 5. Yikes. And typically the I usually comes after, so I would take it either that way or the way we wrote it here. So it could be 1 plus or minus 2 times the square root of 5 over 5I. Either of those I'll take at the moment, okay? Whether you have the I in front or the I behind. All right, so completing the square can get really ugly looking, okay? Which is why a lot of people don't necessarily like it. It's not their favorite, it's not the quickest, but it does work, remember, on every single quadratic that we would have. And that's pretty amazing. Okay, now the other thing that you see down here is roots equals solutions equals zeros. Okay, this is some vocabulary that you're going to want to remember. Okay, if it says what is the root of the quadratic, they're just looking for the solution. Okay, if it's saying what are the solutions, it's the same thing as that. What are the zeros of the quadratic? Those are all the same. Okay, when we're solving quadratics, roots, solutions, and zeros all mean the same thing. All right, have a good one. I'll see you later.